When we think of the hottest planet in our solar system, it's natural to assume it's the one closest to the sun. Our star, a blazing ball of fire, bathes its surrounding planets in heat and light. Mercury, the smallest planet, hugs the sun in a tight orbit. So, it stands to reason that Mercury would be the hottest, right? Well, the cosmos loves to surprise us. The title of the hottest planet actually belongs to Venus, the second planet from the sun. What makes Venus hotter than its closer to the sun neighbor? The answer lies in the atmosphere. Think of it like this. You step out on a sunny day wearing a thick winter coat. You get hotter faster than if you were just wearing a t-shirt. Venus has a very thick atmosphere that traps heat, much like that winter coat. This surprising fact about Venus teaches us that distance isn't everything when it comes to temperature. In the vast expanse of space, things aren't always as they seem. Join us as we delve into the fascinating world of planetary atmospheres and uncover the secrets of Venus's intense heat. In the grand cosmic ballet of our solar system, Mercury and Venus are like two dancers with very different styles. Mercury, the swift and agile one, zips around the sun in a quick 88 days. Venus, on the other hand, takes a more leisurely 225 days for a single orbit. Their distances from the sun are also different. Mercury stays close, always within 47 million kilometers of the sun's warmth. Venus maintains a more respectable distance, circling at about 108 million kilometers. You might think this closer proximity would make Mercury the hotter of the two. However, this is where the dance takes an unexpected turn. Mercury, despite its close relationship with the sun, lacks something crucial, a substantial atmosphere. An atmosphere acts like a planet's personal blanket, trapping heat from the sun and keeping things cozy. Mercury's atmosphere is so thin that it's practically non-existent. Venus, on the other hand, boasts an atmosphere that's anything but thin. It's a dense and heavy shroud composed mainly of carbon dioxide, a potent greenhouse gas. This thick atmosphere acts like a giant blanket, trapping the sun's heat and creating a runaway greenhouse effect. So while Mercury bakes in the sun's direct heat, Venus simmers under its thick atmospheric blanket, experiencing temperatures that would melt lead. It's a cosmic reminder that appearances can be deceiving, and sometimes it's what you don't see that matters most. Let's take a closer look at Mercury, the smallest planet in our solar system. Despite its size, Mercury holds many secrets and surprises that make it a fascinating subject of study. This tiny world is a study in extremes. From its blistering days to its freezing nights, Mercury's environment is unlike any other in our solar system. As it whirls around the sun in its elliptical orbit, Mercury experiences dramatic temperature swings that would make even the most seasoned traveler think twice. Its proximity to the sun means it completes an orbit in just 88 Earth days. Imagine standing on the surface of Mercury. The landscape is barren and rocky, with craters dotting the surface, remnants of ancient impacts. The sun, a dominant presence in the sky, appears 3 times larger and brighter than it does from Earth. Its intense radiation bathes the planet in a relentless heat during the day. The surface temperature can soar to a scorching 430 degrees Celsius or 800 degrees Fahrenheit. This extreme heat is enough to make the surface shimmer with heat waves. That's hot enough to melt lead. The intense heat makes Mercury one of the hottest places in our solar system, but as night falls on Mercury, the temperature plummets dramatically. The lack of atmosphere means there's nothing to retain the heat. Without a substantial atmosphere to trap the sun's heat, the surface quickly loses its warmth to the coldness of space. The night brings a stark contrast to the daytime heat. Temperatures can plunge to a frigid minus 180 degrees Celsius or minus 290 degrees Fahrenheit. This makes Mercury one of the coldest places in our solar system at night. These extreme temperature swings are a direct result of Mercury's thin atmosphere. Unlike Earth, Mercury lacks a thick blanket of gases to moderate its temperature. It's so thin that scientists refer to it as an exosphere rather than a true atmosphere. This exosphere is composed of atoms blasted off the surface by the solar wind. This exosphere is made up of particles blasted from the surface by solar wind and micrometeoroid impacts. These particles are constantly being replenished by these forces. Without a thick atmospheric blanket to regulate its temperature, Mercury experiences the full brunt of the sun's energy during the day and the extreme cold of space at night. This makes for a planet of stark contrasts. It's a harsh and unforgiving world, but one that continues to fascinate scientists studying the dynamics of our solar system. Understanding Mercury helps us learn more about the formation and evolution of planets. Section 4. Venus, shrouded in a blanket of gases. In contrast to Mercury's bare and exposed surface, Venus is a planet shrouded in mystery, hidden beneath a thick veil of clouds. A thick, swirling atmosphere obscures its surface from view, making it a challenge to study from afar. These clouds are not just any clouds, they are composed of sulfuric acid, adding to the planet's enigmatic nature. This atmosphere, while visually stunning with its swirling patterns and vibrant colors, is also the key to understanding Venus's extreme heat and hostile environment. Venus's atmosphere is composed primarily of carbon dioxide, a potent greenhouse gas that plays a crucial role in trapping heat. In fact, carbon dioxide makes up a whopping 96.5% of Venus's atmosphere, creating a dense and heavy blanket around the planet. This thick layer of gas is responsible for the intense greenhouse effect that Venus experiences. Mixed in with the carbon dioxide is a small amount of nitrogen, 3.5%, and traces of other gases, including sulfur dioxide and water vapor, which contribute to the planet's complex atmospheric chemistry. But it's not just the composition of Venus's atmosphere that makes it unique, it's also the immense pressure that it exerts on the surface. At the surface, the atmospheric pressure is 93 times greater than Earth's, equivalent to the pressure found nearly a kilometer beneath the ocean's surface on Earth. That's the equivalent of being 900 meters or 3,000 feet beneath the ocean's surface. This immense pressure would crush any human-made object not specifically designed to withstand it. This dense atmosphere creates a runaway greenhouse effect where the heat is trapped and continuously builds up, leading to extremely high temperatures. Solar radiation from the sun easily penetrates the upper layers of the atmosphere, reaching the surface and heating it up. The surface then radiates this heat back towards space. However, the thick carbon dioxide blanket traps this heat, preventing it from escaping back into space. This process is similar to how a greenhouse works, but on a planetary scale. Imagine a car parked in the sun with its windows rolled up. The sunlight enters the car, heating the interior. The sunlight enters the car, heating the interior. The heat can't escape through the closed windows, causing the temperature inside the car to rise rapidly. The heat can't escape through the closed windows, causing the temperature inside the car to rise rapidly. This is a simple analogy for the greenhouse effect happening on a much larger scale on Venus. This is a simple analogy for the greenhouse effect happening on a much larger scale on Venus. The trapped heat has turned Venus into a scorching inferno. This trapped heat has turned Venus into a scorching inferno, with an average surface temperature of 464 degrees Celsius or 867 degrees Fahrenheit. This makes Venus an incredibly hostile environment. This intense heat makes Venus the hottest planet in our solar system, even hotter than Mercury, despite being farther from the sun. The combination of its thick atmosphere and the runaway greenhouse effect has created a world of extreme conditions. Section 5. The greenhouse effect, a planetary fever. The greenhouse effect is a natural process that occurs on many planets, including Earth. It plays a crucial role in regulating the temperature of a planet, making it possible for life to thrive. It's essential for maintaining a planet's temperature within a habitable range. Without it, our planet would be too cold to support the diverse ecosystems we see today. However, as we see with Venus, the greenhouse effect can also spiral out of control, leading to extreme and inhospitable conditions. Venus, often called Earth's twin due to its similar size and composition, provides a stark contrast in climate. So, how does the greenhouse effect work? Let's break it down step by step. It all starts with the sun. The sun is the primary source of energy for our planet and many others in the solar system. The sun emits radiation, including visible light and infrared radiation, which carries heat. This radiation travels through space and reaches the planets. When this radiation reaches a planet's atmosphere, some of it is reflected back into space, and some of it passes through and reaches the surface. The atmosphere acts as a filter, determining how much radiation gets through. The surface then absorbs some of this radiation and re-emits it as heat, mostly in the form of infrared radiation. This process is crucial for warming the planet's surface. Greenhouse gases such as carbon dioxide, methane, and water vapor in the atmosphere trap this outgoing infrared radiation, preventing it from escaping into space. These gases act like a blanket, keeping the planet warm. This trapped heat warms the planet's surface and lower atmosphere. Without this natural greenhouse effect, our planet would be a frozen wasteland. On Earth, the greenhouse effect is essential for life. It creates a stable climate that allows ecosystems to flourish and supports a wide variety of life forms. It keeps our planet at an average temperature of about 15 degrees Celsius, or 59 degrees Fahrenheit, which is much warmer than it would be without an atmosphere. This temperature balance is vital for maintaining the delicate equilibrium of our environment. However, human activities such as burning fossil fuels and deforestation are increasing the concentration of greenhouse gases in our atmosphere, leading to an enhanced greenhouse effect and global warming. This human-induced change is disrupting the natural balance and causing significant environmental challenges. Venus is a stark reminder of what can happen when the greenhouse effect goes unchecked. The planet's thick atmosphere, composed mainly of carbon dioxide, traps heat so effectively that it creates a runaway greenhouse effect. The thick carbon dioxide atmosphere on Venus traps so much heat that the surface temperature is hot enough to melt lead. This extreme heat makes Venus one of the most inhospitable places in our solar system. It's a cautionary tale for Earth as we grapple with the challenges of climate change and the importance of mitigating our impact on the planet's delicate climate system. By understanding the greenhouse effect and its consequences, we can take steps to protect our environment and ensure a sustainable future for generations to come.